presentation is brought to you by Nikson and Shaw as a part of group project for CS7290 Spring 2020 at Northeastern University. So this project aims to refactor the original code to train the supervised variational autoencoder using the DeepMind's D-Sprite dataset. The dataset consists of 737,280 total images with 5 latent variables like shape, scales, orientation, position X, and position Y. So what we try to do here is to generate a causal story and to infer how the images are affected based on these latent variables using intervention and counterfactuals. So the first step is to install the libraries. The second step is to load to create the encoder functions. Here we have created the backbone of the neural network, how the weights are to be distributed in this neural network model. After that, we have created a CVAE class in which we try to encapsulate the neural networks and the model and guides which are necessary to train the supervised variational autoencoder. After that, in this we have created 3 variables x, y, and z. The z variable is the part to generate an image, the x part is the generated image, the y part contains the latent variables, so this x part is dependent on z and y, that's how the DAG goes. After that, we have created image generator functions. We have split the dataset into training and test part here. After that, we have tried training the model. Here are the parameters that we use for training. We have used the Atom optimizer as it was the best for our case, and here's a sample training we have done. The loss looks okay. It's not the best, but it will do for our project. After that, we have created saving and loading functions, which saves the weights, and this helps us to not to retrain the model again. After that, we have tried visualizing the results from the trained VAE and see how it works. We have loaded a sample image from the test data set and tried reconstruction. Here how it goes. This slider is created from interact function, and as I slide and see various images, we can see the reconstruction looks like it and looks pretty good. After that, we have created another interact function in which we can tune in the latent variables and see how the images look like. Here, if I change the orientation changes. If I change the position changes. After that, we have created certain helper functions, which helps us to encapsulate certain image generating functions and to compare it from the original function. So it makes the work a little bit easier. Here is a sample run of that function. After that, we have created the SEM class. In this, we have created endogenous and exogenous variables, and this helps us to do the counterfactual part of the project as we try to intervene on the example generated from the causal sample generated from the VAE and try to predict what the exogenous variables looks like and retry to generate an image from those exogenous variables. So this class also encapsulates the train part where we train on the conditioned model. So we have done some sanity checks to make sure the VAE works, and here is the generated image, so it works. And we have done another sanity check to make sure how the generated image might look like if the latent variables are changed. So here is the sample, and yes, if I change the shape changes while all of the parameters remain the same. After that, we have tried conditioning on the model and see how the conditioning works. We have tried to condition on the shape and change this value to 1, which represents oval shape, and we have generated 100 samples from it, and the aggregation of these samples result in an image like this. After that, we have tried the counterfactual part. Here what we try to do is predict the exogenous variables from the observed endogenous variables, and to again generate the endogenous variable to see how it works and how the image might look like if the latent variables were to be like certain variables. So here we have chosen these variables to intervene on the model and change this value to 0, 5, 25, and tried to generate samples, and we tried generating samples for it, and this is how the aggregation of these samples looks like. So that's all for the presentation. Thank you for watching.